Okay, in this video I'm going to show you how to create flight delay, flight arrival or flight delay regressions experiment that last time you have already created in the module 3. But I just simplify this project by removing the unnecessary part, which is like joining the data to get the airport name, and then also the visualization. Yeah, so I'm basically just creating the project for the continuation in improving the model. Okay, so PML project flight delay regression. Okay, so 00. Yeah, so starter. Okay, so we're going to use a flight delay dataset. So in the original experiment, you will link to the airport name to get the airport name by joining this two. But I don't need that because I don't need to answer the questions on module 3. Just continue with removing the duplicate row. Yeah, so the step following the module 3 in the DSE. Yeah, okay. So after drag the data, then we're going to remove duplicate row, yeah, based on this column: year, day, month, day of the month, and so on. Yeah, okay. So let's do that. We go back to the Azure Machine Learning, then link this one. After that, yeah, start with no column, and then include the column name, year, and then month, day of the month, carrier, and then origin airport ID, destination airport ID, and then CRS departure time, then CRS arrival time. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah? So if there are 2 rows or more with identical value of this 8 column, that means those are the duplicate. Yeah? So click OK. After that, save it first. Yeah? So let's look at how many of duplicate rows we found and has been eliminated. Yeah? So the original data set, the size is about 2.7 million rows, and yeah, 2.71 million rows. And then after removing the duplicate row, then we will have some remove. Yeah, okay, because we remove the duplicate and retain the first row. Okay. Yeah, so from the 2.71 million, we have yeah, not many, yeah, actually. So still 2.79, but this one is 9397. This one is 9418. Yeah, so about maybe 100 plus. Yeah, okay. So we continue by selecting the clean missing data. Okay, so in the clean missing data, then you're going to have the based on the 2 column, yeah, departure delay and arrival delay. So we check this. Start with no column, the column name, okay, departure delay, and then the arrival delay. Okay, click save it. Yeah. Okay, so the setting is if any of them missing, 0, 1, then a custom substitution value replaced with a 0. Okay, so any missing value for the arrival delay or the departure delay will be replaced with 0. And then we continue with the select column from the dataset. So we're not going to use all of them. We're going to remove some column that based on our knowledge this column are not useful. What are they? So actually this after you did the visualization, yeah? So start with no column, then you're going to include the column such as the month, and then day of the month, and then day of week, and then a carrier, then the origin iPod ID, destination iPod ID, and then CRS departure time, then tap delay, then CRS arrival time, and arrival delay. Okay, so this 1 2 3 4 5 6 7 8 9 10, 10 column. This is following the original project in module 3. Okay, after that we're going to edit metadata by modifying some string column, make it as a categorical. Okay, so what are they? The origin airport ID, there are 3 columns. These 3 columns are basically numeric. The origin airport ID and the destination airport ID are numeric, but the carrier is not numeric. These are 3 numeric, but actually only a code category. So I would like to change to the categorical. Okay, if not, then this will be a big numeric that will be treated as a numeric in the regression's arrival delay calculation. Okay, then normalize the data. Okay, so we normalize the numeric column using the z-score, and then the column selections, we only select the column name CRS departure time, and then departure delay, and then the CRS arrival time. Okay, these are 3. We're going to normalize using the z-score. Okay, then so temporary like that, save, and then let me run first. Just make sure that there is no error. Okay, then after that we're going to train the model by splitting the data first. Okay, just check how many column we have. 10 column, 2.719397. That's the after you normalize. I do the quick check. Yep, that's correct. 2719397, 10 columns. Okay, we're going to split the 70-30. So 70% for the training and 30% for the testing. 70-30. Okay, then after that randomize split. Is there any random? Let's check here. Okay, in the so split the data first. 70-30. Use random value 0. We don't assign any number for the random seed. Okay, then after that drag the boosted decision tree. Regression. Okay, then after that train the model. Okay, after that score the model. and then evaluate. Okay, so we drag here the training, and then the score come here. Okay, so here in the train model we specify what we want to train is the column name arrival delay. Okay, yeah, like that. And then in a boosted decision tree we use the default setting 20, 10, 0.1, yeah, 0.1. The learning rate is slower, but the model is better. And then after that total tree 100, yeah, we don't specify any random, correct? So here yep, 70-30, and then yep, using all the default setting. Boosted decision tree, score the model, evaluate the model. Okay, actually there is no mentions about 0.2 change to 0.1, yeah, but anyway that's right, yeah. Let's do the 0.1. If you want you can keep the 0.2. okay, let's just keep the 0.2. I don't change anything, yeah. Just use the default 0.2 for the learning rate. Okay, save. After that run. Okay, finish the train the model, then we check the evaluate, yeah. Okay, so we have 12.778, and then the coefficient determination is 0.889, yeah. So this number you can write down, or you can screenshot this result, which we're going to compare with the other algorithm. Okay, so let's save this first, and we conclude this the first part, or I put a 0, 0, yeah, because this is just will be used as a starter only. So the next activity is the first activity, which is trying to use the permutations importance features to select the column that not important, then we're going to remove it, yeah? Okay, I will continue in the next video, but at this stage all good. And then we have the benchmark, yeah, or the baseline, or the value that we would like to compare, yeah, which is 12 point this 12.877, yeah, sorry, 12.77, and then 0.889. okay, you can slightly improve this, yeah, I think by changing this learning rate to make it 0.1. let's try, yeah, quickly, yeah. If I change this learning rate to 0.1, then after that I quickly save it, yeah. Then after that run it, yeah. So just now I already put in the screenshot, yeah. This is the when the learning rate is 0.2, yeah, 12.778, and we're going to quickly compare later, yeah, after this training finish. Okay, let's see in the evaluate the model. You see here the root mean square error is higher, yeah, and then coefficient determination is meaning not not better, yeah. So RMSE higher is not better, yeah. This one is better, yeah. And then the coefficient determinations also, this one is not better. This 887, this is 889. Okay, so in that case I will keep the 0.2. That's the best, yeah. So this one is better, 0.2. okay, so all of the setting are from the default setting, and then save and run. And this the the value that we're going to use as a benchmark. Yeah. So okay, I save it. Yeah, save as a starter. Okay, so I'm going to create a new folder, final project, and this is the starter. Yeah, starter metric. So you're going to use this as a baseline. You're going to compare to keep it consistent, this or better. Yeah. We try to reduce the RMSE to less than or about 10 minutes, and then coefficient determination is maintained about 0.7 or 0.8. Okay, so that's the first part of the video. I close, and we'll continue in the next video for the permutations importance features. Okay, thank you for watching.